Hi, this is King of Review. Here we have a function y equals negative log base 5 of x minus 2 squared. And we need to think about the domain of this function. All real numbers except one, except a. We need to know what's the only real number that can't be plugged in for x. Well, let's first think about what this function might look like. I'm going to graph a much simpler version of this function, and that is just the log base 5 of x, ignoring the minus 2, the squared, and the negative. The log base 5 of x looks something like this. Now this line has a domain. The domain is x is greater than 0. All x values greater than 0 are part of this graph. But this graph has what's called an asymptote on the y-axis at x equals 0, meaning the graph gets closer and closer and closer to x equals 0, but never actually reaches it. 0 cannot be put into a log, nor can any negative x values be put into a log. And that's really the key of what's going on here. We have inside our log x minus 2 squared, and we need this number to be greater than 0, so that only the positive numbers are being put into our log function. It doesn't matter that we're then making the answer to our log negative at the end, because again, all that the domain cares about is what x values will work, and only x values that make this inequality true will work. Well, this inequality is nice, because x minus 2 squared is almost always a positive number. If you take any number a and you square it, the lowest number you can possibly get is 0. Some number squared is always at least 0. In fact, it's only equal to 0 if a is 0. And therein lies the issue for us. A squared, any number a squared, is always greater than 0, which is what we want, unless a is equal to 0, unless x minus 2 itself is equal to 0. If x minus 2 equals 0 and we square both sides, we're going to get x minus 2 squared equals 0. And that's a problem. We can't plug 0 into a log. But this is an easy thing to solve. If we have x minus 2 equals 0, we can add 2 on both sides and find that x equals 2 is the number that does not work in our log. So x cannot be equal to 2, and that means that our number a is equal to 2. And that's it. Thanks for watching.